Hello, we're doing problem 18 on page 947. This is the application problem involving arc length. Okay, so a civil engineer is designing a curve on a highway. The curve is going to be the arc of a circle. So that's not always the case, but we're going to keep it simple. This is going to be like a true circle, or at least the arc of it. So it won't be like elliptical or any type of wavy thing, which you see on like railroads. Okay, that gets more complicated, but this is where we begin that discussion. So basically, the road is going to do this. It's probably going to go straight, then it's going to curve, and then it's going to go straight again, which is pretty typical. And from here to here, I'm going to have part of a circle. All right. So an engineer is designing a curve on a highway. The radius is going to be 1,260 feet. The angle that intercepts this curve is going to be pi over 6. So this angle is going to be pi over 6, which is in degrees 30 degrees. But I need to use radians to figure out what the arc length. So I want to find the length of this from point A to point B. My arc formula is the arc length is equal to the radius times the angle in radians. Radius and radians go together. So my arc length is going to be 1,260 times pi over 3. Excuse me, pi over 6. That's why it's better on my dry erase board. Now, it does say to the nearest foot, which means I need to bring in my calculator. So I'm going to do 1,260 times pi. Let's hit enter. And then I'm going to divide that by 6. To the nearest foot, the 7/10 is going to round this up. So to the nearest foot, this is going to be 660 feet. The 659.7 rounds up to 660. And that's it. All you gotta do is multiply the radius times the arc length in radians, estimate pi, and that's how you figure out arc length. All right, good luck.